So our next rule is power rule. The power rule involves raising something to an exponent to another exponent, or a power to a power. So for any real number a and any integers m and m, if I have a raised to the power of m, and then I raise that all to the power of n, then that is just a to the m times n. So like I said, there's an example here, but I'll write another one off to the side. So let's say I had 2 to the third raised 2 to the power of 4. This is going to be messy. So that means 4 times I have 2 to the third. Each 2 to the third expands as well. So that is just going to be 3 times 2 times 2 times 2. That's one group. 2 times 2 times 2. That's another one. 2 times 2 times 2. That's another one. 2 times 2 times 2. And that is my last one. So if we count all my 2's, I'm multiplying together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 2's. Or we could have just done this. 2 to the power of 3 to the power of 4 is just 2 to the power of 3 times 4, which is also just 12. So a power to a power, you multiply the exponents. I find this one gets confused with the product rule a lot, so just be careful that you're paying attention to what it is you're doing. It's an intuitive cross wiring, kind of not exactly intuitive. It's a bit of a cross wiring behind multiplication, and it happens a lot. It happens in a lot of other classes as well. So like I said, you just might make that stumble on that a few times, but eventually you'll get over it. So x to the 6 to the 9. So that means that's just x to the power of 6 times 9, or x to the power of 54. X to the power of 5 raised to the power of negative 4n. So I know this one's a little weird. So this is a power still. You can have exponents in your powers. So that's negative 5 times negative 4n. So that is x to the negative 20n. So this is something you'd see when we're talking about exponential equations. A lot of this you're going to see again when we do exponential equations. Okay, so take a moment and work on these ones on your worksheet. So like I said, pause the video, work on it, and then we'll come back and go through them. Okay. So here we got 3 to the 5th to the 4th. So that is 3 to the power of 5 times 4. So we multiply our exponents. And this is just 3 to the 20th. And this one's a bit of a monster. So when they get really big, sometimes it's okay to not figure out what's actually going to be, because this doesn't even fit in my whole calculator. So in this case, I might just leave it as it is. Because it's really just 3, 4. I gotta count this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, I think. It could be some rounding here, but it's essentially, it's like really close to this right here, if not exactly. But this one doesn't fit in your calculator so well. So sometimes, like I said, if it turns into a real big monster of a number, you can just leave it as 3 to that power. All right, so for B, we have x to the negative 3 times 4y. 4y is my exponent out here. So this is x to the negative 12y. And then C, we have y, and we have 3a as the exponent, all raised to the another power of 2b. So we multiply those together. So this is y to the power of 6ab.